On the largest scales, the universe doesn't look smooth or random. It looks like a vast cosmic web. But what is it made of, and why does it exist? When you gaze up at the night sky, you see a seemingly random spattering of stars and galaxies. But zoom out, far enough to encompass billions of light years, and a hidden architecture emerges. The universe reveals a secret order, an intricate structure on an unimaginable scale. Galaxies aren't just scattered haphazardly through the void like dust motes in a sunbeam. They are organized, forming an enormous, interconnected network that stretches across the entire observable cosmos. This breathtaking structure is known as the cosmic web, and it is the largest and most fundamental pattern in existence. Astronomers first uncovered this grand design not by looking through a single telescope, but by painstakingly mapping the positions of millions upon millions of galaxies in three-dimensional space. What they found was not a uniform distribution, but a cosmic tapestry of immense complexity and startling beauty. The galaxies we see are merely the glittering highlights of this structure, the visible tracers of something far more massive and mysterious. They are like glowing beads threaded onto invisible strings, illuminating a framework that is otherwise completely hidden from our view. These invisible filaments are not made of ordinary matter, the stuff of stars, planets, and ourselves. They are composed almost entirely of dark matter, an enigmatic substance that does not emit, reflect, or absorb any light. Dark matter makes up about 85% of all matter in the universe, and its gravitational influence is the primary force shaping the cosmic landscape. Galaxies form and congregate where the density of this unseen dark matter is highest, lighting up the densest parts of the web while leaving other regions shrouded in darkness. The cosmic web is, in essence, a colossal skeleton of dark matter, and the galaxies we observe are the luminous flesh on its bones. This universal network is defined by its distinct components, each with a unique role in the cosmic ecosystem. The most prominent features are the filaments, long, tenuous bridges of dark matter and gas that span hundreds of millions of light years, connecting the densest regions of the universe. Lining these filaments are countless galaxies, streaming along them like cars on a superhighway. Where these filaments intersect, they form massive, dense hubs called nodes. These nodes are the bustling metropolises of the cosmos, home to enormous galaxy clusters, which are gravitationally bound collections of thousands of galaxies all swirling around a common center of mass. Between these filaments and nodes lie vast, barren expanses known as voids. These are the great deserts of the universe, cosmic underdensities that can be hundreds of millions of light years across, containing very few galaxies and almost no significant structures. Together, the filaments, nodes, and voids create a sponge-like or web-like appearance, giving the cosmic web its name and its profound structural character. The origin story of this magnificent structure begins, not with a bang, but with a whisper. In the first moments after the Big Bang, the universe was an incredibly hot, dense, and almost perfectly uniform soup of energy and particles. Almost, but not quite. At the subatomic level, governed by the laws of quantum mechanics, there were minuscule random fluctuations in density, tiny ripples in the fabric of space-time itself. These quantum fluctuations were unimaginably small, far smaller than an atom, and a fraction of a second after its birth. The universe underwent a period of exponential expansion known as cosmic inflation, stretching these microscopic density variations to astronomical scales. The slightly denser regions became the seeds of all future structure. Over billions of years, gravity took over, acting as the universe's master sculptor. It relentlessly amplified these initial tiny differences, pulling more and more matter into the regions that started out just a fraction denser. Slowly but surely, matter drained from the less dense areas, which expanded to become the voids, and flowed toward the denser regions, which collapsed to form the filaments and nodes of the cosmic web we see today. We cannot see dark matter directly, so how can we be so sure this invisible web exists? One powerful tool is gravitational lensing. According to Einstein's theory of general relativity, massive objects warp the fabric of spacetime around them. As light from distant galaxies travels toward us, its path is bent when it passes by the immense mass of the dark matter filaments. This distortion acts like a cosmic magnifying glass, creating telltale patterns of stretched, warped, or duplicated images of the background galaxies. By meticulously analyzing these subtle distortions in the light from billions of galaxies, astronomers can map the distribution of the intervening dark matter, effectively creating a silhouette of the cosmic web. Furthermore, modern supercomputer simulations have become indispensable in understanding this process. Ambitious projects like the Millennium, Illustris, and Yuchu simulations recreate the evolution of the universe in a virtual box. They begin with the initial conditions measured from the cosmic microwave background, the afterglow of the Big Bang, and apply the fundamental laws of physics, including gravity and the properties of dark matter. These simulations then fast-forward through 13.8 billion years of cosmic history, and what emerges is a digital universe with a large-scale structure that stunningly reproduces the cosmic web observed in the real sky. Validating our theoretical understanding with breathtaking accuracy, the cosmic web is not a static artifact. It is a dynamic, evolving system. Over the vast expanse of cosmic time, the structure of the web has been constantly changing. In the early universe, the filaments were more tenuous and the voids were smaller. As gravity continues its work, the web is becoming more pronounced. The rich get richer as galaxy clusters at the nodes continue to grow, accreting more galaxies and gas that stream in along the filaments. The filaments themselves are slowly thinning out as matter drains from them into the nodes. The voids are growing larger and more empty as they expand. The cosmic web is the universe's transportation network, channeling a steady flow of pristine hydrogen gas along its filaments. This gas serves as the fuel for star formation within galaxies, meaning the web not only dictates where galaxies live, but also governs how they grow and evolve over billions of years. Observing galaxies at different distances is like looking back in time. It's allowing us to piece together a movie of the web's assembly and its profound influence on the life cycle of galaxies. The universe is not chaos. It possesses a deep and elegant structure, a history written in the language of gravity and quantum mechanics, and a grand design shaped by the fundamental laws of nature. There is no magic here, just physics.
Stay curious.